All right, guys, this is Miss Richardson again. You get two videos this week. So for today and tomorrow, we're going to focus on factors and multiples. These are the standards we're covering and our learning target. All right, so to start with, here is a math antics video that will help you figure out how to use a multiplication table. So some of you who haven't memorized all of your math facts, first of all, you need to do that as soon as you can. If you haven't memorized all of them, though, a multiplication table would be helpful while we look at multiples and common factors. All right, so what is a factor? Factors are numbers that can be divided evenly into another number. So for example, if we look at the number 14, 14 has 4 different factors. 2 of the factors are 2 and 7 because 2 times 7 is 14. Another couple of factors of 14 is 1 and 14. So 1 and the number that you're talking about are always factors of any number. To find the factors of a number, you need to find all the numbers that divide evenly into the number with no remainder. For example, if we were going to list the factors of 12, we know that 1 times 12 is 12, so 1 and 12 are factors. 2 times 6 is 12, so 2 and 6 are factors, and also 3 and 4. 3 times 4 is 12, so 3 and 4 are factors as well. So these are all the factors of 12. 1, 2, 3, 4, 6, and 12. What about numbers that only have factors of 1 and itself? Well, those numbers are called prime numbers, like the number 11. The only two factors of 11 are 1 and itself, 11. If you have a number that has multiple factors, more than 2, that means that those numbers are called composite numbers. But 11 is a prime number. Can you think of other prime numbers? Well, the number 3, number 2, number 5, the number 7, the number 13, 17, 19, 29. There's a lot of prime numbers, aren't there? So this would be a great video for you guys to watch. These are called the divisibility rules. For example, every even number we know is divisible by 2. Any number that ends with a 0 we know is divisible by 10. Numbers that end in either 5 or 0 are all divisible by 5. And you do need to know a couple of others. It would be great to know the divisibility rule for the number 4 and also the number 3. So besides 2, 5, and 10, knowing the divisibility rule for the number 3 is the one that I use the most. Okay, so watch that video and try to memorize those rules to figure out if a number is divisible by the digits 1 through 10 or even 11. It might go to 11, I'm not sure. All right, so we can list the factors of these numbers. And the way I do it is I always start with 1. So for 16, I would say 1 factor of 16 is 1, and 1 times 16 is 16. All right, then I go up to the number 2. 2 is a factor of 16 because it's even. 16 times what? 16 times 8. Then I think of the number 3. I know 3 is not a factor of 16. The next number would be 4. 4 times 4 is 16. And then but you don't write 2 4s, even though 4 times 4 is 16. The next number would be 5, 6, 7. None of those are factors. And then my next number would be 8. So since I have an 8 written already, I know I have listed all the factors of 16. All right, what about 9? Well, I know 1 times 9 is 9. 2 is not cannot be divided into 9 evenly, so 2 is not a factor of 9. But 3 times 3 is 9. 9 is not divisible by 4, 5, 6, 7, or 8, and so the number 9 only has 3 factors. All right, so see if you guys can pause the video and find out what the factors of 40, 55, and 17 are. All right, so for 40, we know that 1 times 40 is 40. We know that 2 times 20 is 40. 3 is not a factor of 40. 4 times 10 is 40. 5 times 8 is 40. 5, 6, and 7 are not factors. So since an 8 is already there, I know that I have listed all the factors. All right, did you guys think of the factors of 55? So I know 1 and 55. 2, 3, 4, 5. Yes, 5 times 11. And we're done. And then 17 is a prime number, so I know that there's only 2 factors of 17, 1 and 17. All right, so hopefully you guys got all of those correct. So here is a video by Mr. T. I think his name is Mr. T. Mr. D, I don't know. You guys tell me. So this one's 7.5 minutes long. So he explains about finding the greatest common factor. And I'm going to show you guys how to do that. So when you're given 2 numbers, a lot of times you're asked to find those 2 numbers' greatest common factor. So for example, we have listed out 6 and 12. So finding the greatest common factor, the biggest factor they both have in common, you can list out the digits this way, like we've just been doing. There's all the factors of 6. The second row is all the factors of 12. And you find the largest digit that they both have in common. Another way, which I hope that you guys have been introduced to in the past, and we're going to use throughout this video, because it can not only help you find the greatest common factor, it can also help you find the least common multiple, and that is called the ladder method. So the example given, they're asking, what is the least common multiple of 28 and 18? So instead of listing out all of the factors, we can make a little table like this. It's almost like we're dividing, almost like upside down dividing. So think of any factor of both of these numbers. Well, I know immediately they're both even numbers, so I know I can divide them both by 2. So 2 times what is 24? And the answer is 12. And 2 times what is 18? That answer is 9. Well, then you're going to look at those 2 numbers and think, does 12 and 9, can I divide those 2 digits by a certain number? I can divide them both by 3. Well, that's exactly what I'm going to do. So what times 3 is 12? The answer is 4. What times 3 is 9? The answer is 3. And then when you get to a line that has, when your 2 numbers have no common digits except for 1, because 1 doesn't count, we can't reduce by dividing by 1. When you get to those 2 numbers, you can stop. And the way to find the greatest common factor is you multiply these 2 digits over here on the left. So I know the greatest common factor of 24 and 18 is 2 times 3 is 6. Okay, so I hope you guys have been introduced to that ladder method, and we're going to practice using it a few more times. So there are some directions for doing the ladder method. All right, so you guys, either by doing the listing method or the ladder method, I would love for you to pause the video and see if you can find out the greatest common factor of each of these problems. All right, so I'm going to do 12 and 26. They're both even. Whoops, I almost did it upside down. So since they're both even, I'm going to start with a 2. So 2 times what is 6? 12. I always do that. 2 times what is 12? The answer is 6. 2 times what is 26? The answer is 13. And then look at these 2 digits. Can I divide 6 and 13 by the same number besides 1? The answer is no. So my greatest common factor of 12 and 26 is only 2. That's the answer, 2. All right, let's look at number 3. So now we're going to look at 24 and 36. Well, I'm going to always start with 2 if they're even, and they both are. So half of 24 is 12. Half of 36 is 18. Once again, we have even numbers. So I'm going to divide by 2 again. Half of 12 is 6. Half of 18 is 9. Once again, they have a common factor of 3. So 3 times what is 6? The answer is 2. 3 times what is 9? The answer is 3. 2 and 3 have no common factor. So I'm done. I'm going to take these digits over here. I'm going to multiply them together. So 2 times 2 is 4. 4 times 3 is 12. That's our answer. All right, 21 and 15. The greatest common factor is what? 3. And 36 and 28. Did you guys do that one too? 36 and 28. Let's start with the number 2. Half of 36 is 18. Half of 28 is 14. They're both even, so I'm going to divide by 2 again. 9 and 7. 9 and 7 have no common factor, so I'm simply multiplying 2 times 2 together, and I get 4. All right, did you guys get them all? I hope you did. There we go. Awesome. All right, so now we know what factors are. What about multiples? So one way I like to tell kids to remember these are factors are small numbers, multiples are large numbers. Each number only has a certain number of factors, but every number in the world has an unlimited amount of multiples because you can find a multiple of any number forever and ever and ever. So what I mean by that is just some multiples of 2 are 2, 4, 6, 8, 10, 12, 14, 16, 18, so on and so forth, right? So we can multiply the number 2 by every number we could think of and create a multiple. Some of the multiples of 3 are 3, 6, 9, 12, 15, 18, 30, 60. Those are multiples of 3. Multiples of 5 all end in either 0 or 5. If one number is a multiple of the other, it will divide exactly with no remainder. Okay, so 12 is a multiple of 2 because we can divide 12 by 2 and get a whole number. Same thing with 15. 15 is a multiple of 3 because 15 divided by 3 is a whole number. All right, here's a video, 3-minute video about multiples if you need to go back and watch it. So let's practice. List the first 7 multiples of each number. And all you do in your brain is think like this example right here. 1 times 7, 7 times 2, 7 times 3, 7 times 4, so on and so forth. 12 times 1 is 12. 12 times 2 is 24. 12 times 3 is 36. 20. Think of those multiples. And these are the answers. Now, we did stop after the 7th digit, but like I said, you can go on and on and on forever because you can continuously make new multiples of any digit. How do you feel? Does that make sense? All right, so when you're wanting to find the least common multiple, you're asking what is the smallest number that both, this example says 3 and 12. What's the smallest number I can divide by both 3 and 12? Okay, so this is a good video that will show you how to do that. One way you can find the least common multiple is just simply write out the multiples of each number. For example, they did the multiples of 3 and the multiples of 4. And then you're going to circle the least common multiple, and 0 doesn't count, just like 1 doesn't count as a factor. I mean, 1 is a factor of every number, but when you're trying to find the least common multiple, the smallest number they both have in common besides 0 is 12. So the least common multiple of 3 and 4 is 12. All right, so let's practice. But this time we're going to use our ladder method to help us find the least common multiple. So the ladder method is good, not just for least common or greatest common factor, but also least common multiple. So let's start with 9 and 15. So just like we did before, we're going to think, is there a number that I can divide 15 and 9 and 15 by? The answer is 3. So 3 times what is 9? 3. 3 times what is 15? 5. All right, so then there are no common factors between 3 and 5 besides 1, and 1 doesn't help us. So we know our least common, I always have to think about this when I say it, guys. Our greatest common factor of 9 and 15 is 3, but then we can use this chart to find the least common multiple. And what we do is we take our 3 and we multiply it by the 2 numbers left on the bottom row. Okay, so 3 times 3 is 9, and 9 times 5 is 45. So if I listed out the first several multiples of 5 and the first several multiples of 15, the smallest number that they both have in common is 45. All right, so let's do 12 and 20. I'm going to change the screen so I have more room. 12 and 20 is the next one. So let's do 12 and 20. And you guys practice the ladder method with me, especially those who've never used it before. So we're going to start just like we were finding greatest common factor. What can we divide 12 and 20 by? The answer is 2. So 2 times what is 12? 2 times what is 20? These numbers are both even, so we're going to divide by 2 again. So 2 times what is 6? 2 times what is 10? All right, finally, 5 and 3 have no common factor, so we stop. So if I was asking what is the greatest common factor, the answer would be 12, not 12. 2 times 2 is 4. But now we're finding least common multiple. So now we're going to multiply all of the numbers on the side and on the bottom. So we have 12 times 3 is 36. And no, I don't know why I'm saying 12. 2 times 2 is 4. 4 times 3 is 12. And 12 times 5 is 60. So the least common multiple of 12 and 20 is 60. All right, the next two digits is 2 and 3. Now that one we don't need a ladder method by because these are very small numbers. So I'm just going to list out the multiples of 2. 2 times 1, 2 times 2, 2 times 3, 2 times 4. All right, I could go on and on. And then what about 3? 3 times 1, 3 times 2, 3 times 3. All right, and I can stop because I already see that the smallest number that they both have in common is 6. The least common multiple of 3 and 2 is 6. All right, and then we have a 22. I think I have enough space down here to do 6 and 22. So I'm going to start by dividing them both by 2. So 22 divided by 2 is 11. 6 divided by 2 is 3. And that's as far as I can go because 3 and 11 do not have common factors. So to get my least common multiple, I'm going to multiply all 3 of these numbers. So 2 times 11 is 22, and 22 times 3 is 66. All right, guys. I hope that made sense. I hope you guys got the right answers. Were you doing these with me? And there they are. Yay, we got them all right. All right, so check out this video. Another way to find the factors and multiples of pairs of numbers. This is the ladder method explained a different way. So those of you who that will help, please read through all of those directions. Here's another video talking about the ladder method of GCF, greatest common factor, and LCM, least common multiple. It's a good video you can watch if you need it. All right, so now we're going to talk about factoring and the distributive property. So if you are going to factor, basically you take two numbers like 24 and 16, and you want to think of their greatest common factor. Okay, so I think we did these two numbers earlier. I might be wrong, but the greatest common factor of 24 and 60 is 12. I can divide both 24 and 60 by 12. So that's basically what you do. You pull out a 12 from both of these numbers, and then you think, okay, so if I divide 24 by 12, what do I get? I get a 2. If I divide 60 by 12, what do I get? 5. Okay, so these two expressions are equal to each other. So if I wanted to double check how my factoring, make sure my factoring is correct, I would simply distribute the 12 to both digits in the parentheses. 12 times 2 is 24, and 12 times 5 is 60. All right, so let's do a couple of examples, so hopefully it'll make more sense to you. Here's a good video about equivalent expressions with the distributive property. It's only 2 minutes long if you need to come back and look at this. All right, so let's start by using the distributive property. The way I would distribute it is I multiply everything in the parentheses by 3. So 3 times 4 is 12. I'm going to bring it over my plus symbol. And 3 times 2 is 6. And I have just used the distributive property on this problem. I've shown the distributive property to you, okay? Now, if I want to go back and check this, obviously I know that 12 plus 6 is 18. If I want to use order of operations, I would add 4 and 2 and get 6, and 6 times 3 is 18. I know they're equal. But we're just practicing writing using the distributive property right now. All right, so let's distribute our 2. So what's 2 times 6? And what's 2 times 2? 4. So I've just rewritten this expression a different way that is equivalent. All right, you guys try the last two. So 4 times 1 plus 4 times 2. And the last one, 5 times 3 plus, whoops, 5 times 3 plus 5 times 7. All right, that was pretty easy, wasn't it? All right, so now we're going to practice factoring by pulling out the greatest common factor. So the first thing you want to do is figure out what is the greatest common factor of 21 and 14. Hopefully you realize that's 7. And then what's left in the parentheses is what you get if you divide each of these digits by 7. So 21 divided by 7 is 3, plus 14 divided by 7 is 2. And we have just factored this expression. Let's try the next one. What is the biggest number I can divide 9 and 12 by? The answer is 3. So what's left in the parentheses? 9 divided by 3 is 3, and 12 divided by 3 is 4. And we have distributed. All right, what about the next one? Now I'm going to show you what happens if I don't pull out the greatest common factor. Okay, so on this one, for example, I know that I can divide 18 and 24 by 2. 2 is a common factor. So 18 divided by 2 is 9, and 24 divided by 2 is 12. Well, I did pull out a common factor, but not the greatest common factor. And the way I know that is I realize 9 and 12 can both be divided by the same digit. So if you don't pull out the greatest common factor, that's going to happen. You're going to find that these two numbers in the parentheses still have a common factor. So if I had thought about all of the digits, I would realize that 6 is the greatest common factor. I mean, this is correct, you guys. This is equivalent to this one. It's just not the greatest common factor. But what if I divided both of those digits by 6? 18 divided by 6 is 3, and 24 divided by 6 is 4. And now I've simplified it all the way down. What is divisible? What is 55 and 30 both divisible by? The answer is 5. And I have in the parentheses 11 plus 6. All right, did you guys do the last one? Hopefully you used 4, not 2. If you use 2, it's not simplified all the way. So what's inside the parentheses? And I just realized 4. Not even 4 is the greatest common factor, is it? It's 8. So what's left in the parentheses? 2 plus 3. Now 2 and 3 have no common factors. So even though this is equivalent and this is right, 4 is a common factor. It's not the greatest common factor. All right, so there are some more that I would love for you guys to practice. These were in the slide deck, and the answers are on the next slide. And then there's a couple more slides that are some practice problems. So I want you guys to go back to the slide deck and give these a try. Not only will you work on this obviously today, tomorrow as well, but on Monday and Tuesday of next week, you have some problems dealing with everything that we've discussed today. All right, guys. Well, I hope you guys have a great day. And if you need me, let me know, and I will check in with you guys later.